is going to be possibly a slightly longer one than the miscellaneous topics. This one's going to be on the most favorable conditions for types of supercells to form. Hopefully we should all know what a supercell is at this point. And for the website that I got most of this presentation's info on, it's iweathernet.com/thunderstorms/3 types of supercells. 3 types, there's 4. So like I just said, there's 3. Okay, well I guess there is a type. There's 1 type and 3 modes, I'll put it that way. They are classic, low precipitation, high precipitation, and then your 1 mode, because that one can't really do much, is miniature. The reason why they are called modes is because supercells are dynamic. When you think of a type, you think of something staying the way it is until it's no more. And that is very technically true for supercells. Usually a classic will become the classic mode will go over to becoming a high precipitation mode, and that'll be the end of the changes. However, this is not always the case. I mean, come on, it's weather, there's always an exception. There have been times where a classic will go to high precipitation, then the high precip will revert back to classic, then the classic possibly will revert back to a high precip mode. And very, very brief overview of a supercell. It is not the entire storm, as is seen in this simple diagram from Weather Underground. It needs a rotating updraft, and that part is what creates the tornado. That's called the mesocyclone sometimes, although usually the pronounced lowering, circled here, the bottom left image, is the mesocyclone. And there may even be another lowering of that as well, which would be a wall cloud. And as you can see here, supercells vary wildly in size. This image here from the lower right comes from Skip Talbot, one of his videos. Highly recommend you go check him out. But classics themselves vary wildly in size. High precips are usually larger, as I'll say again later, and your low precips are, well, they're something. But let's jump right into it. Your classic supercells, a diagram of which is seen here, and 2 examples from the December 18 outbreak, seen here at the top middle, and one in May 2010, seen here at the bottom middle. So classic supercells will have your aloft wind speeds of around 40 to 60 knots, 46 to 69 miles per hour. Knots and miles per hour are actually very similar. I think you multiply the knots by like 1.15 or something like that. As you can see here, the very tops are quite strong. And this one right here, the 4th one down from the top, is 50. So, oof. And your mid-levels are going to be usually below 50 knots or around 57 miles per hour. Pardon me. The classic supercell is called by tornado chasers sometimes as the Goldilocks of supercells. It is photogenic for all of the rain that it makes, but it doesn't produce too much rain usually that a tornado becomes rain-wrapped. And you're going to have your CAPE usually of 2,000 joules per kilogram. The fat in between here is not CAPE, but shows that that's what tornadoes want, actually. Tornadoes want this fat in between. This sounding, by the way, that I'm referencing is from May 21st, 17, as you can read here, and was taken by a Dodge City, Kansas weather balloon. The CAPE is seen here at the very bottom and is on the higher end of 2947 joules per kilogram. Last but not least, about the classic cell, there will be rain in both downdrafts. Supercells almost always have two downdrafts, the forward flank, which is forward of the supercell, and the rear flank, which is just around it or obviously rear of most of the action. That rear flank rain is especially seen here at this top middle image from the Havana 18 cell. And you could definitely see the forward flank in both of them, with the 2010 cell really having a big one. So your miniature cell is the only type, although technically not, technically is. I'm going to call it a type because it can't really do much. But a mini cell, miniature supercell, is a small classic. These form in the cooler season usually and are pretty low topped. We're talking a max of 35,000 feet or 10.6 kilometers, which is just around mid height for a supercell and most thunderstorms in general. Most thunderstorms grow to around 40,000 feet, so and to have this maxed at that is a bit of a yikes for them, but you know. On from that, the reason why these are low topped is because there is less cape at around 1,000 to 1,500 joules per kilogram, and therefore less to lift, or buoyancy as it's sometimes called. So they're unable to form very tall because of that. And due to that as well, they rarely produce tornadoes. These are sometimes called the most photogenic supercells by storm chasers looking to photograph them. And if they do produce a tornado, then it's a happy day for them storage chaser with a camera because they're going to get some good photos. On to the next mode of supercell, the low precip supercell, or LP, looking a little weaker than your classic, and that's for a reason. These are also usually more tilted than normal, and that's because you have your aloft winds of more than 60 knots, or equal or more than, which is equal or more than 69, again, nice, miles per hour, as seen here in this sounding from a Norman NWS weather balloon. These high winds completely erase all of the rain from the cell's updraft, either pushing it further away, which creates a very small forward flank region, or completely wipes it away and there's 100% no rain with this cell whatsoever. And these med levels are going to be around 40 knots, possibly even 50. So just around your classic, but again, with these high winds of 60, you're not going to have a good chance of having rain with these. I mean, these are called low precip cells. What do you expect? These are going to have cape of around 1,500 joules per kilogram. Pictured here, we actually have a lower cape than normal here of 1,303. And this little tiny thin in between is not what tornadoes want, despite it being quite long. And a very good picture of a low precip cell is seen here in the bottom right. And as you can read here after the cape, these last part about these cells is that they are more common in drier environments or environs. Drier environs already don't have a lot of moisture to provide a cell, so when combining that with your aloft winds, you're not going to be having rain with these. Now, the complete opposite of that is going to be your high or heavy precipitation supercell, or HPs. Examples seen here at the top middle and bottom middle. First off, as you can see from the two examples, they tend to be larger, also seen in this side view diagram, and pretty darn healthy looking. These cells are going to have your aloft winds of equal to or less than 35 knots, not 45, but 35 knots is around 40 miles per hour. You're going to have relatively little draft separation. Draft separation is separating your updraft from your downdraft. This is important for any thunderstorm and will definitely happen with your low precip cells. And when those two merge, when your updraft and downdrafts merge, that will choke off the storm, essentially chokes itself off. But when you have a little draft separation, that can actually benefit the storm because the downdraft is pushing all the rain down, the updraft is pushing all that rain up. So you're going to have your hail, you're going to have a lot of rain. High precip cells. This is high precip. I expect a lot of precipitation. I expect the rain. After that, from your draft separation, you're going to have your cape that may possibly exceed 4,000 joules per kilogram. 4,000 joules per kilogram, by the way, is considered extreme by the NWS. And I don't think I've ever seen in my area a cape of 4,000. But from this sounding, it is 5,228 at its highest. The other two, that's surface cape. Mixed layer, you have 3626, and your last one, which is a FCST surface, Fix-It Felix surface, 5270 joules per kilogram of cape. So nothing to sneeze at in the slightest from that sounding. And this very, very fat in between is a red flag. On top of this, well, I guess at the bottom of this, low base heights are common because of the amount of moisture that high precip cells run into. High precip cells, when they are transferred over, when a classic cell, I'll rephrase, when a classic cell becomes a high precip cell, or transfers over to become a high precip mode, it is because it has encountered enough moisture that it can produce even more rain and likely even more hail. And again, like I said at the very beginning, usually this transfer only happens once, but it can go back. A heavy precip supercell can switch back to becoming a classic if it runs out of that moisture, which it usually doesn't. And a example of the rain shadowing that'll occur from a high precip cell. And as you can read here above this photo, both this photo and the sounding are from the 2013 El Reno F5, EF5 I should say, which, yes, had the cape of 5228, not 2528. What am I talking about? 5,000 joules per kilogram. Absolutely insane. And if you guys don't know already, the 2013 El Reno tornado is the largest tornado in terms of size ever recorded. So, kind of a big deal. And another devastating AF5 is the Joplin, Missouri tornado, and that is this bottom middle image there. So you might be asking which one is the most dangerous. Is it going to be your low precip? Well, from what I already stated, I'm going to rule this one out immediately. These ones rarely produce tornadoes. They rarely occur at night usually. And again, there's little to no precip. It's a low precip after all. So you're likely not even going to get your hail. So why did I include this one? I'm a doofus, aren't I? Yes. Your high precip just talked about these and how dangerous they can be. However, you also have your other very likely contender as your classic. I mean, both of these are very dangerous. These account for the majority of your tornadoes. The very broad answer is that all of them can be hazardous, especially when they're tornadic. All tornadoes are dangerous. Please never, ever underestimate a tornado, especially if that tornado is fast moving, or at night, or a combination of both, or even rain wrapped. The true answer, though, is your high precipitation. Your high precipitation supercell is your most dangerous. This is because it has your much, much larger precipitation region, very, very large rear and forward flank downdrafts. These cells usually will have hail too. It's not a question of if you'll get hail, it'll just be when, if you're being affected by a high precip, that is. Your bear's cage as well is going to be much more hazardous. This tornado will likely be rain wrapped and will be unable to be seen by the naked eye. And the absolute perfect, yay, thank you, high precipitation supercells. They have the worst tendency to produce the most violent tornadoes. The 2013 El Reno, 2011 F5 from Joplin, another 2011 cell from the same outbreak as Joplin from in Moore, Oklahoma, which is relatively close to El Reno. Like, come on. The Gwynn, Alabama F5 from the 74 outbreak too. Last but not least, as you can read here, these will likely be the biggest creator of your worst case scenario, a tornado that is fast moving, rain wrapped, and at night. That is your deadliest possible combo, and is exactly what happened with the Gwynn, Alabama F5 from the 74 outbreak, like I said before. It's what happened with the Joplin F5, EF5. However, I mean, granted, this cell was not at night, and it was not necessarily fast moving. This is the case with the exception of at night, what happened possibly with the tri-state tornado. I mean, hell, the tri-state tornado is the fastest moving tornado in terms of forward speed ever to date, and that happened in 1925. But again, little note here, the tendency to spawn the most violent tornadoes doesn't mean it's true. Classic supercells have produced F5s, and I only just learned this recently, actually, but the US has actually gone more than 3,000 days without a EF5, so that's good, despite the number of high precip cells we've gotten, despite the number of classic cells we've gotten. A reminder, biggest reminder is that your most violent tornadoes are your rarest. EF5s and EF4s do not happen that often. In the case of super outbreaks, the greatest example being the 74 super, yes, they were likely because of the conditions. But under relatively normal conditions for a tornado outbreak, they are not. Many tornado outbreaks do not produce the F5s. And that is where I'm going to have to end it. So, obviously, biggest takeaway, your most dangerous supercell, your high precip. Second place is your classic. Last place is it's going to be have to tie between the low precip and the miniature. I mean, how low precips usually just stay low precips, so they're technically a type as well. So, But that is all that I have for you guys. This was a little bit of a longer, miscellaneous one, and I kind of like doing these ones about supercells. I mean, some other ones I'm not the most fond of, but I'll still do them anyway. they're shorter, but that's all that I have for y'all for this video. Thank you guys so much for watching until the end, and I'll see you guys in the next one.